The decimal representation of a fraction is either terminating or non-terminating recurring. What does this mean? In this video, I will examine this using a couple of examples. The first example I'll take up is the fraction 3 over 8. The value of 3 over 8 can be found by dividing 3 by 8. Let us go ahead and do this. 8 is greater than 3, so I put a 0 here. 8 times 0 is 0. 3 minus 0 equals 3. To proceed further, I'll put a decimal point here and a 0 after the decimal point. I'll put a decimal point in the quotient too. I'll bring down the 0 to get 30. 8 times 3 equals 24. 30 minus 24 equals 6. I put a 0 again and bring it down. 8 times 7 is 56. 60 minus 56 equals 4. I put a 0 again and bring it down. 8 times 5 equals 40. 40 minus 40 is 0 and I am done. So the decimal representation of 3 over 8 is 0.375. The digits after the decimal point have terminated, and hence we call this decimal representation as terminating. Let us now examine whether this will be the case always. That is, will the decimal representation of a fraction always terminate, or are there cases where the opposite happens, that is, it doesn't terminate? If so, why does it not terminate, and what exactly happens in such cases? To examine this, I will take up another example, say 2 over 7. Again, the value of 2 over 7 can be found by dividing 2 by 7. Let us go ahead and do that. 7 is greater than 2, so I put a 0 here. 7 times 0 is 0. 2 minus 0 equals 2. To proceed further, I'll put a decimal point here and a 0 after the decimal point. I'll put a decimal point in the quotient too. I'll bring down the 0 to get 20. 7 times 2 is 14. 20 minus 14 equals 6. I put a 0 again and bring it down. 7 times 8 equals 56. 60 minus 56 equals 4. Put a 0 again and bring it down. 7 times 5 equals 35. 40 minus 35 is 5. Put a 0 again and bring it down. 7 times 7 equals 49. 50 minus 49 equals 1. Put a 0 again and bring it down. 7 times 1 equals 7. 10 minus 7 equals 3. I have run out of space here, so I will write down the 3 here and continue. As before, I put a 0 and bring it down. 7 times 4 equals 28. 30 minus 28 is 2. Put a 0 again and bring it down. 7 times 2 equals 14. 20 minus 14 equals 6. Put a 0 again and bring it down. 7 times 8 equals 56. 60 minus 56 equals 4. Put a 0 again and bring it down. 7 times 5 equals 35. 40 minus 35 equals 5. Put a 0 again and bring it down. 7 times 7 equals 49. 50 minus 49 equals 1. Again, I have run out of space, so I'll write the 1 here and continue. As before, I put a 0 again and bring it down. 7 times 1 equals 7. 10 minus 7 equals 3. Put a 0 again and bring it down. 7 times 4 equals 28. 30 minus 28 equals 2. Looks like I can go on and on, but is that really so? And if so, why is that so? For that, let us stop and look at the quotient. As we can see here, it looks like the block of digits 285714 is repeating. But why is that happening? Since we are dividing by 7, what remains or is left over at each stage of the division process can only be in the range 0 to 7 minus 1, that is 6. Or in other words, 0, 1, 2, 3, 4, 5 or 6. Let us look at the first few remainders that we got in our division process. Our first remainder was 2. Next we got 6. Then we have 4. Then 5. Then 1. And then 3. Whatever we get next has to be from this set only. However, there is not much choice left. If we get 0 next, the decimal representation terminates, which we already saw in the previous example. Anything else, and it has already appeared before. And since all we are doing is putting a 0 and dividing, the entire sequence is going to repeat over and over. In our case, we got 2 next. And what this means is that our next remainders are again going to be 6, 4, 5, 1 and 3. This sequence of 2, 6, 4, 5, 1, 3 as the remainders is going to keep on repeating it. And obviously this means that we are going to see a repetition of digits in the quotient too. So the decimal representation in this case will be non-terminating but recurring. That is, a sequence of digits, namely 285714, is going to repeat or recur over and over again. We show this by writing the decimal representation of 2 over 7 as 0.2855714 with a bar like this to show that this sequence of digits keeps repeating forever. We took a couple of examples, but it is easy to see using the logic presented that when it comes to the decimal representation of a fraction, only 2 cases are possible. It can either be terminating or non-terminating recurring. In a subsequent video, I intend to examine how to go about finding out whether the decimal representation of a fraction is terminating or non-terminating recurring. I hope you found this video useful. If you have any comments or suggestions, please let me know. Also, if you feel that someone you know can benefit from this video, please share with them. If you are interested in more such videos, please subscribe to my channel. Thanks for watching.